Hey guys, welcome back. Quadratic equations and functions revision. We continue doing problem solving and let's see what we covered up to now. There are about, I guess, 7 problems revealed. Yeah, that was the last one dedicated to work done. Alright, so we're gonna go to and start from 8. So two numbers, if added together, have the sum of 10 and the difference of their reciprocals is 1. Okay, so let's convert each statement into algebraic equation. So you've got two numbers, let's say A and B. There are two numbers. If you add them together, you have the sum of 10. Alright, and the difference of their reciprocals. So if you have a number, reciprocal means this number to the power of -1, according to the index notation, or you just simply flip it over. In case of fraction, let's say your a, for example, 2/3, reciprocal number is 3/2. Okay, this how the mechanism works. So, alright, we've got a difference of their reciprocals. Let's take the difference of their reciprocals according to the definition of what reciprocal is. And we've got 1 as a result. So we need to find the numbers. Simply, we need to solve simultaneous equations. So make sure you remember how to work it out. But be careful here, it's not linear. As in all previous cases, it's going to be quadratic one. So some part of linear and another is quadratic. So let's do that. So normally, the substitution method works best. You express a through b. Let's say 10 minus b, it's a. You simply put the right hand side of your equation for a. You just put instead of a. Okay, so let's use the second equation. Now let's complete what we've got. So 1 over a, which a is 10 minus b. You subtract 1 over b as well, and you've got 1. So normally, how to resolve this equation? So normally you need to work on actually common denominator. Let's do that. So this sort of algebraic fractions, in order to find a common denominator, you take in multiplication of both, right? So your common denominator is b times 10 minus b. And what do you do next? You're doing the crisscross. So b goes here and multiply by 1. So you've got 1 times b. And then 10 minus b goes here and you multiply by 1. So you subtract, because you have the minus sign here, you subtract 10 minus b, multiply by 1. Okay. That's how your fraction looks like. Okay, so let's see what we've got here. So we've got the following: b minus 10 minus b. Okay, so I just simplified it. So b minus 10 and simply plus b, because minus and plus will give you minus. Sorry, two minuses will give you a plus. Okay, that's what we have. Equals to b times 10 minus b. And that result equals to 1. Okay, I just simplified that. And that's our almost the last equation that we're going to explore. Okay, so guys, have a look there. That's what we have. So I just erase because I need a space. Alright, let's see that. So what we've got, we need to solve that one. So first of all, we cancel b. Oh no, we're not able to cancel in this case. Sorry, my bad. Okay, so we've got 2b minus 10 over b times 10 minus b. And that's equal to 1. However, I would like to use fractional. So you saw many times that we came to, in our course, we came to fractional equations, and now we just need to resolve it. Okay, so what we're going to do, we're going to do crisscross multiplication. Okay, so let's do that. And because there are ones, we're simply multiplying b 10 minus b by 1 and crisscross the same. Okay, so let's see what we've got. We've got the following: 2b minus 10 multiplied by 1. There is no effect. So equals to b times 10 minus b. And now what we've got just normal quadratic equation. Let's see why I think so. Because 2b minus 10 equals to, if we expand, we've got 10b minus b squared, from where we can transfer all the terms to the left side. Why? Because I won't have positive coefficient before the leading term. So I've got the following. From there, I can get b squared, then plus 2b, then I transferred 10b with negative sign minus 10b, and minus 10 equals to 0. So that's almost the last equation that we have, and we just simply make it easier and say minus ab and minus 10. That will be a result in quadratic equations. Okay, so we're gonna use quadratic formula. Let's calculate b. It's minus 8, so 8 plus minus square root of discriminant is negative 8 squared, which is 64, minus 4 times negative 10, so it's plus 40, all right, over 2. Let's simplify that. Square root plus minus square root of 104 and over 2. Okay, so we've got that everything in order to find our b. So I'll erase that. And now what we're gonna do, we're going to use calculator. Okay, so my goal is to calculate b values. So we don't have any restrictions. So we've got two numbers, no matter which they are, like they might be natural, positive, negative integers, they might be rationals, because obviously we're going to have cert here, square root of number that it cannot be calculated precisely, so that's why it's a rational. Okay, let's see. Use a calculator and first add square root of 104 and then totally divide by 2. Okay, so what I've got for when I use plus, I've got 90999. So I've got 9.1 if we round to 2 decimal place. Okay, so that's what I've got for b. So what about the second one? The second is going to be negative, definitely. Let me see. Yeah, it's going to be 10999 again. So I simply round up to 2 decimal place. So 2 dp. Alright, so I've got values for b. And now it's time to figure out a. So what a is simply 10 minus b from there. We already expressed it, and now we've got 10 minus b. So for b1 is 10 minus 9.1, and for b2 is 10 minus minus, so we've got positive sign in the end. So that's the final value. Okay, let's calculate. So the first one, we've got 0.9, and here we've got 11.1. Alright, so we've got A and B corresponding. So we have two pairs. Simply, the first one is A1, B1, and the second one is A2 and B2. So make sure you got the same. Alright, so that was pretty easy. About two numbers. So hope you understand that. And see you later, guys.